Today's video, we are going to look at linear programming, and this is our third video from the topic linear programming. So for those that have been following, make sure that you catch up. For those that have not followed from where we started from, I encourage you actually to go back to those videos and then come back to this video so that you can gain some understanding with the well-connected concept. However, for those that have been following, it is going to be easy and straightforward. So without much further ado, let us now dive into this video or second part of linear programming. So we'll look at how to shade which part on the X or Y plane should you actually shade. Okay. So sometimes you can actually have something like this. And then what you have now is what is called the X or Y plane. Now this X or Y plane has got actually two axes, the X axis as well as the Y axis. So you can just label them like that. Then the intersection is 0. Okay. Now from there, sometimes you can be asked to, let's say for example, you want to shade, okay? You want to actually shade which part of the X or Y plane will actually contain the solution, okay? So sometimes you can have, let's say for example, let's have X equals, X greater than 3, okay? So we have something like this. Now, onto this video, what is going to happen actually is that we are not going to fill up the X or Y plane, the graph, with all the possible numbers based on the range that you have. What we're just going to do is look at this one in a simple term, okay? And this is very fundamental for understanding, okay? So when you have something like this, okay, then what the examiner wants, or what the examiner means, is that he wants you to give them the values of X that are greater than 3, okay, but shouldn't we actually start from 3? So from there, what they want is, they want something like starting from 4, 5, 6, and so on, okay? So this implies that on this X or Y plane, we have to now show this in terms of shading, okay? In terms of shading, okay? So which part of the X or Y plane must we actually shade, okay? Now from this same concept, okay, the other key fundamental that you're supposed to understand is that because X is just greater than 3, which implies that the 3 in this expression is not part of the solution, okay? And what that tells you or mean is that when you're going to draw this line in terms of shading, this line is going to be a dotted line, okay? A dotted line like this one, okay? Now, why dotted line is because there is no qualifier of equal to, so it just says X is greater than 3, because X is not part of the solution. So when you are putting the line, this expression on the graph paper, then what you're supposed to do is to ensure that the line is drawn as dotted, which implies that the number in the expression, which is 3, is not part of the solution. Now, again, when you look at this X or Y plane, we are saying that we have the positive on this side, we have the negative this side. And on the Y, which is vertical, we have the negative downward, we have the positive upward. So what you're supposed to do is just get these 3, and it is positive, then just sort of like approximate to say 3 can be somewhere there, okay? 3 can be somewhere there. Now, once you do that, you get your ruler now, okay? You just draw a straight line, okay? Because you are talking about linear programming, and linear comes from the word line, a straight line, okay? So from there, you just do like this. Okay. Now, once you do that, now at the very end of the line, at the end point, you just say x equals 3. Okay. X equals 3. So from there now, we know that we just now have to shade now which side of this line is actually having the solution, such as a 4, 5, 6. Okay. Now, this is very powerful and very fundamental, because once you begin to understand which part of the line are we going to shade to, okay, it is that point, okay, that is going to separate what we call the wanted region and also the unwanted region. Now, the moment you begin to know how to shade, which part of the line are we supposed to shade and what kind of a line am I supposed to draw, okay, am I supposed to draw? And the moment you understand those key concepts, the fundamentals, then you can answer literally any question that you can come across. So remember that if there is no quantifier which says greater than or equal to, okay, you can see that it's saying x is actually greater than or equal to. So that, I mean, x is just greater than. So meaning there is no equal to. So the part of the solution that you're going to form will not actually include 3, okay, because 3 is not part of the solution. And from the graph, then it can be seen that the line should be a dotted line, which validates to say, because there is the 3, okay, the 3 is not part of the solution, okay, and this is the reason why we dot, okay, despite the line passing at 3, okay. So from there, we are going to now shade the part. Okay. Now, what I want you to understand is this: when you are shading the part, you have to understand very well, okay? Because some people make some mistakes when it comes to that. So what this implies that when you're saying that x is greater than 3, what you're supposed to do is now, when I'm on this line, okay, when I move from 3 going to the right, the numbers keeps on increasing. And those are the things that I want. So I want numbers or the values of x such as 4, 5, 6, and so on. So as long as I keep going to the right from 3 all the way up to the right, it implies that I'm increasing. And that is what, those are the values that I want. And that is the part of the solution which satisfy this expression. Okay, so what you're supposed to do now is you shade the opposite. So you shade the opposite, so I'm going to shade the part that is less than, because you can see that I'm not looking for those values that are less than. So from there, then I can shade the part that is less than. Okay, and the way you do this is just do this. Okay, so your shading should actually be very neat and very smart. Yeah, you don't have just to shade anyhow as if you are a grade 1 doing some kind of a drawing or some kind of art. Okay, so that is the most important thing to understand. So now the part that we want, okay, is this: x is greater than 3. Okay, implies that the remaining, the unshaded part is actually the wanted region. And normally we see as we move on, this is referred to as the ARA region, the wanted region. So that is basically how you can go into the idea of shading. Okay, so thank you so much. Okay, so thank you so much, and this is basically, very simple. It's about understanding the key fundamentals when it comes to linear programming. Okay, so if you have a question, you need help, you can just actually comment in the comment section, or you can also WhatsApp me on the following line, which is 0964 460218, or direct call 0775826 390. So thank you so much, and I'll see you in the next video.